Welcome back to the Atari ST Nostalgia GFA Basic Tour, and boy is it long ago since I said this. And it's not really a return, it's sort of return, because this is not a video where we will learn anything new. This is more a correction video where I will actually learn to follow my own teachings. Because I got a comment on my part 35 video that the examples in that video actually did not work on a 512K machine. And there might actually be other examples that also don't work on a 512K machine, because I only ever tested them on a 1 megabyte machine. And my bye-bye mono demo will actually only work on at least 1 megabyte by design due to all the pre-shifting. But these particular examples should actually be able to work on a 512K machine. So we have to correct this, we have to troubleshoot. So let's actually test the code on a 512K machine from the interpreter, see what goes wrong, and then see how we can quickly solve it. So I have opened my trusty GFA Basic interpreter after a very long time. I've actually went to the files of the part 25 video, and I'm going to open the second example, which has a lot of code. And the first thing I'm going to do is I'm just going to run it to see what actually goes wrong. And I'll do a Shift F10 to run, and it will immediately return an error while reserve. And if I return, it actually goes to the part of the code where the error is, and you can see that I'm actually using the reserve command to reserve 256,000 bytes, which is well below 512,000 bytes. But let's go back to what we actually learned in part 30 about memory operations, because remember, in my previous examples we had 1 megabyte of RAM, but a lot of that RAM is already eaten up by the TOS and GEM and then the GFI interpreter itself. And then some more is actually reserved for screen memory, right at the top of the memory. And on a 1 megabyte machine, that's still not really a problem, because the 256,000 bytes, I can reserve that for my code and my arrays, and then we still have plenty of room left for allocating graphics, buffers and such. But in part 3, I also very clearly stated, remember to reserve less to be able to allocate more. And that is not what I'm doing here, because look what happens if I try the same with just half the memory. There's just absolutely no way I can reserve that amount of memory of RAM on top of the interpreter, let alone then do the extra memory allocations I need and then still leave some room for the screen memory. It just doesn't fit. And this means I clearly did not follow my own teachings. So how do we solve this? Because remember that not using the reserve command, like in this case I just use a RAM to comment it out, and then also I've disabled my error correction that I made for this. GFA will just basically now try to claim all available space, and then with my error connection turned off, the code will crash after it does the malloc step, because the malloc command will have no room, it will fail. It will return a 0 value to the variable, and then the code will just bomb out in a bus error as soon as we try to write to it, which you can clearly see. If I do 2 bumps bus error, that's because it tries to write at address 0. So that's not the solution. The solution is indeed to follow my teachings and indeed reserve less to allocate more. And I'm using memory snapshots here, so it's going to be quite fast. So I will open my code again, and in this case I will go to the general preparations procedure, which contains the reserve command. And very quickly, instead of 256,000, let's just do 32,000. And if I run it on the interpreter now, you can see that the code is actually working just fine. So it was very easy to solve by following my own teachings, and I will actually also load the other example where I have to do the same error correction in general preparations. Instead of doing 256,000, I can even just do remove this 6. This should even be enough, because there's not so much code and just a few arrays that don't take up that much space. And now, even on a 512K machine, the code actually works just fine. So yeah, that was an easy way to correct myself. I was called out in the comments, and therefore I corrected myself, because that is the right thing to do. I also corrected the code and uploaded it to the GitHub page, or I will do after editing this video. I'm not going to check the rest of my code for the same error, because yeah, that's just too much work. If you find it, just let me know. I will correct and upload that code as well, if it's possible for a 512K machine. Code that was specifically written for 1 megabyte machines only, I will not correct, because it's not possible. But for now, I would like to thank you for watching. Thank you for joining me in troubleshooting my own code and making me learn to follow my own teachings. And I hope to see you soon in the next video.